Hi, welcome to the Online Chemistry Tutor YouTube channel. Steve here. In this clip, we're going to have a look at ionic compounds involving molecular ions. They're a little bit more complicated than the ones that we looked at in the previous video clip. So this is the data sheet again, and I'm going to begin with a question for you. If you're not sure about it, a hint will appear in just a moment. The question is, which ions are molecular? If you think you can identify the molecular ions, go ahead and pause the video now and have a go. If you're not sure where to start, then here is a hint for you. The hint is that molecular ions contain more than one atom within them. So if you want to have a go and see if you can identify which ions in this list on the data sheet are molecular, you should pause the video clip now. I'm going to go through the answers in 5, 4, 3, 2, 1. Okay, so on the left-hand side, you're looking for ions that contain more than one atom. You're looking for ions that contain more than one capital letter in effect. And there's actually only one. It's ammonium here, NH4+. That's the only one from the left-hand side that contains more than one. When you look at the right, well, chloride is only one, bromide is only one, fluoride and iodide are only one. But hydroxide, contains two. It contains oxygen and hydrogen. Nitrate contains nitrogen and oxygen. You've got hydroxide, you've got nitrate. Not oxide, not sulfide. Sulfate contains 1 sulfur and 4 oxygen atoms within it. And carbonate contains 1 carbon and 3 oxygen atoms. So on this particular list, there are 4 molecular ions. I'm going to show you how you sometimes have to be aware of additional rules when it comes to working out the formula of an ionic compound that contains these particular ions. If you use a data sheet in lessons or you have a list of ions like this in your book, my advice to you is to identify which ones are molecular and use a highlight pen to actually highlight these particular ions. And it will remind you that when you have to use these ions to work out a formula, to just be aware of what you have to do slightly differently to work out the formula of the compound compared to those that don't require the use of molecular ions. Okay, so let's have a look at an example. What is the formula of sodium hydroxide? So just like the examples on the previous video, you find the ions. There is sodium and there is hydroxide. So just like before, write them out next to each other. Na is single plus, hydroxide is OH minus. Add the charges just like before. Sodium is +1, hydroxide is -1. Charges add up to 0, nice and easy, NaOH. You don't have to do any more with this one. The formula of sodium hydroxide is NaOH. This is a formula that you'll see time and time again. It's a very important chemical. Okay, so let's try a different example. The formula of lithium sulfate. Li is single plus, sulfate is SO4 2 minus. There they are on the sheet. So if we add up the charges, we've got +1, we've got -2. They will add up to -1. And you'll recall from last time, if the compound has too much negative charge, you can introduce some more positive charge. 1 + 1 - 2 = 0. Problem solved. The ions now cancel out. We have 2 lithium ions and 1 sulfate ion. Li2, SO4. Okay, next example, the formula of magnesium nitrate. You might be starting to feel a little bit more confident now, so if you want to try it yourself, pause the video. I'll do the answer in 3, 2, 1. Magnesium is Mg2+, nitrate is NO3-. Find them from the list. There's magnesium, there's nitrate. Now, if you're feeling confident and you had a go at this, what you will have noticed is that you need a second nitrate ion, because at the moment the charges add up to +1. So you need more negative charge. NO3, we need a second NO3 minus. Now, when it comes to writing down the formula of this compound, what you've got to bear in mind is that if we have two lots of NO3 minus, our compound as a whole is going to have 2 nitrogens within it and 6 oxygens within it. Now, because nitrate is a molecular ion and we need more than one, the way that we show people that this compound contains 2 nitrates is by putting it in brackets, like so. So it only applies if you need more than one molecular ion. That's the thing to remember. Okay, so here's another example, ammonium sulfide. Again, if you feel like you can do it, have a go, pause the clip, answer in 3, 2, 1. Ammonium is about halfway down on the left, there it is. Sulfide is 3 from the bottom on the right. Write them out next to each other. NH4 single plus, S2 minus. Where are we with the charges? Well, we have a +1, we have a -2. At the moment, our compound has too much negative charge, so we need another ammonium ion. Now, remember for the previous example, if you need more than one molecular ion in the compound, you have to put it in brackets. Our compound contains 2 ammonium ions and 1 sulfide ion. So NH4 in brackets with a 2 and then S, ammonium sulfide. I can't emphasize this strongly enough. The only time you use brackets is with molecular ions and only if you need more than one ion to write out the correct formula. When I teach this and I introduce this idea of using brackets for molecular ions, some students start to use brackets all the time. They will start writing out things like this for magnesium chloride. And I have to make the point that no, you don't do it for chloride because chloride is not a molecular ion. A chloride contains 1 chloride. So the brackets are simply not required. Another mistake that you might see is if you were asked to do the formula of magnesium hydroxide. So we have 1 magnesium and 2 hydroxides. We need the brackets for the hydroxide. But if you leave the brackets out, you sometimes see it. This is wrong because if you look at the formula as written, it suggests 1 magnesium, 1 oxygen, and 2 hydrogens. Well, magnesium hydroxide contains 1 magnesium ion and 2 hydroxide ions. So it has to have 2 oxygens and 2 hydrogens. That's why we need the brackets. So you only use the brackets with molecular ions and only when the formula contains more than 1. Remember the example sodium hydroxide from the beginning. 1 sodium ion, 1 hydroxide ion. Don't put the hydroxide in brackets because there's only 1 of them. Okay, I think I've made my point. All right then, time for you to have a go. I've got 4 examples for you. Pause the video clip now. I will run through the answers in 5, 4, 3, 2, 1. Magnesium sulfate. Magnesium on the left-hand side is 6 from the bottom. It's Mg2+. Sulfate is 2nd from the bottom on the right. SO4, 2-. The charges of +2 and -2 cancel out completely. We have 1 magnesium ion, 1 sulfate ion. So the formula is just MgSO4. No brackets around the sulfate because there's only 1 of them. Next example, ammonium nitrate. You can have compounds with a molecular positive and a molecular negative ion like this. It's not a problem, you just treat them the way that we've been looking at the ones so far. We have 1 ammonium ion, 1 nitrate ion together, the charges cancel out, +1 and -1. So the formula becomes NH4, NO3 3. No brackets required because we only have one of each ion. So next example, ammonium sulfate. We know that ammonium is NH4 single plus. Sulfate is SO4 2 minus. So the charges don't cancel out now because we have +1 and we have -2. They add up to -1, so we need some more positive charge. We can put in a second ammonium ion. The ions now add up to 0. 2 plus on the left, 2 minus for the one sulfate. So we have 2 ammonium ions, 1 sulfate ion. Ammonium is a molecular ion, so we need the brackets, like so. And finally, iron 3 hydroxide. Iron 3 is second from the bottom on the left. It's Fe3+. Hydroxide is OH-. So we have 3 pluses and we have 1 minus. In order for the charges to add up to 0, we need some more negative charge. We need 3 lots of negative charge to balance out the positive and the negative. So iron 3 hydroxide contains 1 iron 3 ion and 3 hydroxide ions. So its formula will be Fe, open brackets, OH, close brackets, 3. Thanks for watching. I hope you found this video clip useful. Feedback is welcome. If you need help with your studies, please don't hesitate to get in touch. Thank you very much and goodbye.